Alright, our first lecture is over the law of conservation of mass. You should know the definitions of these terms. They're given in the textbook, so I'm not going through them, but we're going to focus on the law of conservation of mass. And that states what we can't lose or gain mass during a chemical or physical process. Whatever the mass is that we start with, we end up with the same mass. In a chemical reaction, we can rearrange the atoms, but we don't lose any of them along the way. So we can use this to our advantage to figure out a few different kinds of problems. I have three here that we're going to try, three different ones. Let's look at this first one here. A block of wood weighing 134 grams and 101 grams of oxygen gas are heated inside of a closed container. That's really important. That closed container assures that we can't lose any of the mass. Everything's trapped inside. After several minutes, the heat is removed, and remaining in the container are 97 grams of charred wood and soot, and an unknown mass of various gases. What is the total mass of these gases? So this isn't your standard kind of chemical reaction, but we can certainly write it the way we would write a chemical reaction. We have block of wood. Normally we deal with pure compounds or elements. We don't deal with mixtures like this in a chemical reaction, but we can write it in this way. Block of wood plus oxygen produces charred wood plus soot plus gases. Now, the law of conservation of mass says that the mass of the reactants must equal the mass of the products. So let's write down everything that we have here. They have given us that there's the block of wood weighed 134 grams. We reacted with oxygen, 101. So since it's charred wood, obviously we didn't go to completion. We just kind of burned it up a little bit. And the charred wood and soot together are 97 grams. And then the gases are an unknown. So we just write it as X. Now, the mass of the reactants have to equal the mass of the product. So 134 plus 101 must equal 97 plus X. And then it's a matter of solving for X. So on this side it would be 235 grams, 97 grams plus X. So X is just, I'm on page here, 235 grams minus 97 grams. And we have 138 grams for the gases. So applying the law of conservation of mass, we're given everything except for one species, and we can solve for it. That's what's going to happen in all of these types of problems. All right, so that's a kind of a very vague, general kind of reaction because we don't know what was in the wood. We don't know what the gases were, but we can still solve it because all they really want to know is the mass of the unknown gases, and we found that. But let's look at another one. This is a physical process of mixing. A student is assigned the task of dissolving 5 grams of sodium chloride and 5 grams of potassium chloride in 500 grams of distilled water in a 600 ml beaker. The beaker weighs 85 grams. He adds the correct mass of sodium chloride, but when he attempts to add the correct mass of potassium chloride, he spills some compound on the floor. The student adds the remaining KCl to the beaker. How can he determine the amount of KCl that was lost? So you should pause the video and give it some thought. And it's always a good idea to, I'm going to solve these problems anyway, see if you can do it on your own, and then come back. But now, we know that, let's write down what we know. Here we have NaCl plus KCl plus water plus beaker is our total mass. And we know that we have 5 grams that we weighed out. 5 grams of the KCl, we lost some, but we know we measured out 5 grams. We have 500 mils of the water and 85 grams, actually it's 500 grams of water and 85 grams of for the beaker. So the total mass should have been when the student was done. So 585, so this would be 595. That's what it should have been. But we know that the student lost some. So if we, but the rest of the KCl, lost some of the KCl, and the rest of the KCl went in, along with everything else. So if you were to weigh what he has, what he would find is a mass less than this, because he lost some of the KCl. But by a difference, we subtract what he found finally on the balance, subtract it from 595. That has to be the mass of the missing KCl. Law of conservation of mass says it must be. So let's say that he, assuming the total mass of the system was found to be 593, what was the mass of the KCl lost? So 595 grams minus 593 gives us 2 grams of KCl lost. And there's no question about that. As long as everything else was weighed out perfectly, and he knows that he started out with 5 grams of KCl that he was making his way towards the beaker with before he lost it, then the amount that went on the floor must be 2 grams. All right, so, and here's a third type of problem. This one is an actual chemical reaction involving pure elements and compounds, rather than a mixture like in the earlier one. So to consider this reaction, we have carbon tetrachloride plus bromine goes to dibromodichloromethane plus chlorine. And make sure it's balanced out, yep. And we have 154 grams of carbon tetrachloride. Let's just write this out as we go. And I'm going to rewrite the reaction to make it a little larger. Easier to work with. Make sure it's on the screen here. So 154 grams of the carbon tetrachloride is reacted with bromine. They don't say how much, so that must be our X. Both reactants are completely used up. That's important, so there's nothing left over. So the mass of reactants is converted all the way over to products, and so that will be the same, equal the same mass as the original reactants. 243 grams of dibromodichloromethane goes right here. And then it's 71 grams of chlorine. All right, so again, we know from the law of conservation of mass that the mass of the reactants must equal the mass of products. So get this right. So we have 4, so that'd be 314 grams, 154 grams plus X. And then X is equal to 314 minus 154. And I think I can do that in my head. I think that's 160, but I'll double check. Yep. And so the mass of the bromine, that was used to react with your 154 grams of carbon tetrachloride. So these are the 3 types of problems that cover many of the types you'd see on an exam. There's really an infinite number, but really we have a chemical reaction with pure compounds, and we have one that's just a general one involving everyday objects, and then we have a physical process. It's kind of a little mystery of what happened to or how much of the KCl was lost. Those are the ones that come to mind. Those are the ones that you're most likely to see on most exams.